Hi, this is Chuck Wesley James with Cellusys, and today we're going to talk about the goals and value proposition behind 5G network technology. We've come from 3G to 4G or LTE, now we're moving into 5G. Why? Why is the industry doing this to us when we've just implemented or are still implementing LTE 4G network? Well, first a little history. We did 2G. 2G gave us mobile voice. It really was the first time we had decent quality mobile voice. 3G introduced mobile data. Now, 4G introduced faster data, but it also had a secondary benefit of providing better building penetration on those radio waves. And this is where you really started losing, you stopped having dropped calls and you stopped having large amounts of jitter as you walked into an elevator. And that sort of thing has benefited from LTE. Now, 5G has got a whole set. It's got three main goals, and I call them a triangle of goals. So let's take a look at what they are. The first one is this fast bandwidth. This is really providing what, if you live in the city and you have an ADSL connection, your Wi-Fi experience, but on your handset as you travel, as you get outside of the city, as you get into an area where you don't use something like a fixed backhaul like ADSL. On the lower right-hand corner, we look at super low latency. This is not for voice. These are for applications that really cannot lose access to their central server and need to be able to do so very quickly in near real time. Looking at the lower left, we've got massive connectivity. We've got billions of IoT devices that now need to connect, and the 5G network is going to try and do that as well. Let's get into a bit more specifics, and we'll take a look at each one of these three goals in a bit more detail. So faster bandwidth. I live in the city. I've got a great ADSL service. My Wi-Fi experience is really great. But as I leave my home and I go outside the city, I don't have an ADSL backhaul, and my speed in LTE starts decreasing. Well, 5G is going to give me much faster bandwidth, huge bandwidth, in fact, more than I would ever as a personal user even need. This isn't needed for voice or even HD voice. And I'll show you why that is later on. So this is really the carrier response to that backhaul situation. I won't need an ADSL connection even in the city once we have a really big 5G connection to me. Super low latency. Oh, here we're looking at applications like a connected car. Now, if it's a connected car that somehow needs to talk to its server to make its decisions, then things get a little scarier. You don't want that car to ever lose connectivity to its central server. So some sort of car or drone is what we're looking at here. It's not a huge amount of data we're talking about, but it is time critical and reliability is super required. Okay? So this is real-time or near real-time applications. That third goal for 5G is this massive connectivity. This is where the Internet of Things come in. Now, this is things like your electrical meter, your water meter. Now, they're not going to be making a whole lot of data requirements on the network, but they are going to be doing it once in a while. And that there are billions of them because it's not just your electrical meter and your water meter. It's going to be your coffee maker, your refrigerator, your doorbell, the video connected to your doorbell to see who's at your front door. All these massive numbers of devices are going to connect to the internet, and the 5G network wants to be a part of that. So it's billions of devices. They have fairly low usage. Along with low usage comes with a low cost expectation. While you might be willing to pay $50 for your handset to connect to the internet, you're certainly not going to be able to do that for your water meter and another $50 for your electrical meter and for your doorbell and all these other things. So there's a low cost expectation here with these devices that have low usage and low bandwidth. They also have a very high tolerance to latency. If there's a delay in getting your electric usage back to the electrical company so they can bill you, a few seconds here or there is definitely not going to be an issue. A few minutes won't be an issue on that one. So they have a very high tolerance to latency as opposed to our other applications doing super low latency. So you can see these three goals are actually looking at completely different areas of the network, and they need different things. So the IETF came up with this triangle of things. Let's look at a few of the items inside of this triangle. Voice. Voice is somewhere in the middle. Your ear does not hear very high frequency. So we don't really need to go to a super high bandwidth in order to get you super high fidelity. Your ear just isn't going to hear it. Similarly, you don't actually notice certain delays and jitters when you're having a phone call. Your ear just is not that perspective of it. So voice is somewhere in the middle. It's not really the reason behind 5G at all. Internet of Things, the first one, that's a massive numbers of sensors, from water meters to refrigerators to doorbells. There are billions of devices that will be coming on stream, and we need some way to connect those back to whatever server they need to talk to. Low cost, low bandwidth, and quite a lot of tolerance to latencies and delays. Virtual reality applications, they're kind of somewhere in the middle. Um, They take a fair bit of data, more than your standard voice call does. Of course, you're getting audio and video, and you want to respond fairly quickly. If I turn my head in a VR game, if there's a delay of more than 20 milliseconds before that video changes, I'm going to notice that difference. So we want to be able to do that pretty fast. Now, Wi-Fi speeds everywhere. So as I mentioned, in my house with a great ADSL connection, my Wi-Fi experience is really good. It goes back over the internet really quickly. But as I leave the city, that is an issue. The 5G carriers will be able to pick that up as I'm moving around with my handset and continue a real, what I'll call a Wi-Fi or better experience based on my 5G connections. And then we get down to the super low latency. Lots of reliability. We don't want that car off without its server barreling down the street. Low latency. There's a lot of input coming from that car very quickly. We want to be able to do it. So that's where the self-driving car sort of application would come in. So how are they going to accomplish this? First of all, there's some radio changes. There's 3 spectrum bands that are being used in 5G. So the radio changes a bit for 5G. There's a concept called network slicing, an end-to-end pipe. Um, you can think of this in the old circuit switch days where we would actually nail up copper. Well, obviously it's packet, we're not nailing up copper, but there was no decision to be made for that data. It knew where it was going. So doing a network slicing or making an end-to-end pipe sets up where all that data along that end-to-end pipe is going to go ahead of time. So each individual router or system in between doesn't need to open it up, look at the headers and parse it out and figure out where to send it. It's all set up. It comes in on this connection, goes out on that connection, and it speeds things up dramatically. Those of you who are familiar with frame relay will have the same idea on the X25 network from 20, 30 years ago. There are some changes taking place in the core network. So carriers can use the 4G network, the HSSs and MMEs, P gateways, serving gateways. Those can all be used in the 5G. However, in full 5G mode, that network starts to separate out the user plane and the control plane even further. So you can have an S gateway which only does control functionality, and S gateway which only does user functionality. And the reason for doing that is that you can start to scale up and down the number of gateways according to your requirements. Maybe for these applications you require more control gateways than user gateways, or vice versa. You can have one control gateway managing a whole lot of S gateways which are doing at the user plane. And in a virtual cloud environment, when this IMS core and EPC core are running on a cloud environment, spinning up new S gateways or P gateways should be part of the cloud infrastructure and be able to do that. That's why we've separated out the user and control plane even further. There's still diameter networks. Certainly if you're using a 4G network, you still are using diameter for a lot of the control plane. That hasn't gone away, and it still contains the same diameter security issues that exist today, take place in that same scenario. So a little background on Cellusys. Cellusys, we're based out of Ireland. We have offices around the world. We work in roaming, security, and analytics, principally on the SS7, diameter, and GTP networks. So this is things like steering of roaming or roam welcome. On the security front, big issues these days in hacking of SS7 diameter GTP networks, taking over cell phones, eavesdropping. You certainly don't want that connected car to be taken over in the IoT space. So signaling firewall, SMS firewalls, those are uh, very important these days. Analytics, to be able to understand what you're doing with roaming and security, is another third pillar of what Cellusys takes care and looks after. So that concludes my short presentation on 5G. Thanks for listening. Contact information from Cellusys is on the screen now, and I hope to hear from you again. Thanks. Bye.